The shipping lane challenge. As if earthquake faults and powerful currents weren't enough obstacles, the Gibraltar Strait presents a third engineering nightmare that moves in plain sight. Every 7 minutes, day and night, another massive vessel navigates this narrow channel, creating a shipping superhighway that any bridge or tunnel design would have to accommodate without disruption. Inside the Gibraltar Vessel Traffic Service Control Center, Captain Alejandro Morales monitors a wall of screens displaying the real-time positions of dozens of ships approaching the strait from both the Mediterranean and Atlantic sides. "What you're seeing is normal traffic for a Tuesday morning," Captain Morales explains, gesturing toward a screen where colored triangles representing vessels move slowly across the digital map. "We'll track approximately 300 ships passing through today, which adds up to over 100,000 vessels annually, from container megaships longer than 3 football fields to oil tankers, cruise liners, military vessels, and fishing boats. This diversity makes Gibraltar one of the world's 5 busiest waterways, all funneling through a strait just 7.7 miles at its tightest point." Captain Morales recalls a harrowing incident from last winter. "We had a container ship lose power during a Levante wind event. The vessel started drifting toward the Spanish coast with no ability to maneuver. Our team had just minutes to coordinate tugboats to prevent a disaster. These waters forgive no mistakes." The Ever Given incident in the Suez Canal showed the world what happens when a major maritime passage gets blocked, he continues, referencing the 2021 grounding that disrupted global supply chains for weeks. "And the Suez is significantly wider than our strait. We simply cannot afford any disruption here. Any bridge spanning Gibraltar would need to accommodate the world's largest vessels without restriction. The latest generation of container ships, like the Ever Lot, stand at a towering 76 meters above the waterline when fully loaded. Add the necessary safety margin for vessel clearance during storms and high seas, and engineers would need to design a bridge with a minimum clearance of approximately 85 meters, nearly as tall as the Statue of Liberty. Creating that kind of clearance creates a compounding problem," explains Dr. Wei Zhang, a structural engineer who has consulted on maritime crossing projects worldwide. "The physics of bridge design means the higher your clearance, the longer your spans need to be. Longer spans require stronger support towers, which in turn need larger, deeper foundations. Exactly what the unstable seabed here can't reliably provide. This engineering cascade leads to a sobering reality. A bridge at Gibraltar would require central spans approaching 5 kilometers in length while maintaining unprecedented heights. The world's current longest bridge span, the 1,991-meter central section of Turkey's Çanakkale Bridge, would need to be more than doubled. The construction process itself presents further complications. Building supports would require partial closures of shipping lanes for periods potentially lasting months, with enormous economic consequences. Approximately 20% of global maritime trade and 40% of Europe's energy imports pass through here, Captain Morales explains. Even a partial restriction creates massive backups. 4 time-sensitive cargo, from fresh produce to manufacturing components, delays can render entire shipments worthless. A comprehensive study by the European Maritime Safety Agency estimates that each day of restricted access through Gibraltar would cost global supply chains approximately €2.3 billion, with construction likely requiring intermittent restrictions over 5 to 8 years. The cumulative economic impact could exceed the actual construction costs. The tunnel alternative eliminates clearance concerns but introduces its own complications. Traditional tunneling methods would still require massive platforms in the waterway during construction, creating navigation hazards in lanes where vessels already contend with powerful currents. People don't realize that many of these ships take over 2 kilometers to stop, Captain Morales adds. They're like moving cities with limited maneuverability. If a vessel suffers propulsion failure while approaching a construction platform during a strong current, prevention options are limited. The International Maritime Organization records show that narrow channels with fixed obstacles experience collision rates nearly 3 times higher than open waterways, a particularly concerning statistic for the already challenging Gibraltar Strait. Beyond